Factoring is a big topic we'll deal with, some in pre-algebra and then more extensively in Algebra 1. And you'll do more after that too, but kind of the introduction happens in these two classes. Now you've done factor trees before with numbers. Breaking down something like a 12, you might say, okay, well that's a 2 and a 6 and then a 2 and a 3. So you got the prime factors 2, 2, and 3. What we're doing is similar, only we're doing it with variables involved and with more than one term. And what makes it similar is that we're trying to take something that's built from other things and break it down into what pieces at their most basic level build them. So this is kind of the most basic level of factoring. I should just say the first level of factoring. So a reminder, you've done greatest common factor before, probably in elementary school. Just to remind you what it is. It's the largest factor that all the numbers share. So for example, 12, 20, and 24, they could all be divided by 2 evenly. They could all be divided by 4 evenly. And we're never going to be worried about if it can be divided by 1, because every whole number can be divided by 1, and that doesn't really accomplish anything. So whenever we say what goes into them evenly, we're implying other than 1. So these are the only two numbers that go evenly into all 3 of these. And the bigger of them is 4, so it is called the greatest common factor. And I bring this up because what we're going to do is we're going to look at terms, figure out what's their greatest common factor, and we'll pull that out of them. Another way you can think about factoring as the distributive property in reverse. So just a reminder about the distributive property. That's where we said if we have a number outside the parentheses, we can multiply by the first number. 3 times 2x is 6x. Then multiply by the second number. 3 times 5 is 15. So while this was the answer, this right here was the answer to when we were told to distribute, we're going to start with it as our question when we're asked to factor. So we look at these two terms, 6x and 15. And we say, what's the greatest common factor for the two of them? What's a number that would go into both of them evenly? And we want to make sure it's the biggest number that would go into both of them evenly. So for these two, that would be 3. So I take a 3 and I put it outside, and I start a parenthesis. And just like with the distributive property, we were multiplying by both things. With factoring, since we're doing it in reverse, we're going to be dividing both things. In other words, since I recognize 3 is the biggest number that goes into both of these, I now do 6 divided by 3, which is 2, and I leave the x with it. Because I could say 6x divided by 3 is 2x. Then I keep the minus sign, just like you keep the minus sign when you distribute, we'll keep the minus sign when we're factoring. Then we do 15 divided by 3 and get 5. So if you notice, what started as our answer when we were distributing became our question, and what started as our question with distributing became our answer. So I understand that might seem like it's just a big circle, and it does appear that way, but there are reasons to do both of these things at different times, which we'll get into more why we factor as we go on in the school year. So let's try these down here. Factor the following. So again, we've got two terms, 2x and 8. We want to say what number goes evenly, what's the biggest number that goes evenly into both 2 and 8? And that would be 2. So I put a 2 out front, start a parenthesis. 2x divided by 2 is 1x. You can just write x, you don't have to put the 1. Plus 8 divided by 2 is 4. Now we look at this, we say, okay, what do these two terms have in common? They both have 3. So I put a 3 out front, start a parenthesis. 3x divided by 3 is 1x. 9 divided by 3 is 3. And I'm not going to require you to check your work, but one way you can check to make sure you did it correctly is look at your answer and then distribute that number. If you were distributing, you'd say 3 times x is 3x. 3 times 3 is 9. So it does match up very well with what we started with. Now C is a little bit different. There is an understood 1 in front of that x squared, but there's nothing 5 and 1 have in common other than 1, which doesn't help us at all. But there is something that these two terms have in common. It's not a number, it's a variable. They both have an x. So this time I can put x out front. So then I'm doing x squared divided by x, which is x, 5x divided by x, which is 5. Again, if you distribute, you see we have the same thing. X times x is x squared. X times 5 is 5x. And if it helps you, I know some people get tripped up with this x squared divided by x. You've got to remember that x squared means x times x. So I could take one x and put it out front, and the other x stays inside. I also kind of think of it as we have two x's here. And I don't mean it's 2 times x. I just mean it's an x times an x. So there's two of them being multiplied together. So I can pull one of them away, and when I pull one of them away, there's still one left over. So we'll see something similar on D. 3 and 4 don't have anything in common other than 1, so no number to pull out. But these both do have an x, so I'll pull an x out. So the 3 just stays. If I take one of those x's away, and one's left, the 4 stays, but I took away that x, so there's no more x in this term. Because I divided this by x and got 3x, divided this by x and got 4. And as you can see, x times 3x, 3x squared, x times 4 is 4x. So we are breaking this down into its simpler pieces. These are the most basic pieces we can break it down into to show what this is made of. Just like we did with the number 12 up here at the top. Okay, yes, it does get more complicated on the back, but it's still the same process. And what I would encourage you to do is think about the numbers first, then look at the variables. So 36 and 11. They actually don't have any number in common. No greatest common factor for them, so we don't pull a number out. But I see both of them do have an M, so I pull that out front. And both of them have at least one N. Now this has one N, this has two of them multiplied together, but I can only pull out one of them because I can't pull more out than one of them has. Okay, so if I pull out an M and an N, this is left with just 36. I pull out an M and just one of the N's, so 11 is left and one of the N's is left. Just like we talked about on the front when you had x squared, you can pull one of them out front and one of them's left inside. Okay, very important factor, not an intended pun, darn it. A very important thing to remember when we're factoring. You can only factor things out if every single term listed has them in common. That's not too hard to remember when there's just two terms. When there's three, sometimes people will say, oh, well, I see these two have this in common, but this one doesn't have it. Can I pull that out? No. It has to be something all three have in common for us to be able to pull it out. So first we look at the numbers. 20, 4, and 16. Those are all divisible by 4, so I can pull that out. Then I see a variable z, nobody else has that. A y, nobody else has that. X, nobody else has that. So the variables just stay where they are. 20 divided by 4 is 5. 4 divided by 4 is 1. 16 divided by 4 is 4, and we leave the x squared. Okay, on part C, 4 and 7 don't have any number in common, but notice this has 3 x's and this has 2, so we can actually pull out an x squared this time, because you can pull out as many as you want as long as both of them have that much. So since the smallest number of x's we have is 2 of them being multiplied together, we can pull both those out. So the 4 stays where it is. We took away 2 of these, so there's still 1 left. The 7 stays, but we pulled both of these away, so this term now has no x. And you can distribute to see that this works, that this is equivalent to what we started with. Okay, D. Look at the numbers first. 20 and 5. They both have a 5 in common. Okay, only this one has an x. Nothing we can do there. This one has 3 y's multiplied together. This one has 2. So we can pull 2 y's, y squared, out front. So 20 divided by 5 is 4. The x didn't change, so it stays. We pulled 2 of the y's away, leaving 1 behind. And 5 divided by 5 is 1, and the y squareds are all taken away. Now this is an important thing, because lots of people will make this term disappear, because they're thinking, oh, we took this whole thing out, so it's just gone, and they'll just have the answer like this. But that's not correct, because we've got to remember we're dividing when we factor. We divided 20xy cubed by 5y squared and got this value. We divided 5y squared by 5y squared. So that leaves a 1, not a 0. Okay, E, we look at the numbers first. All these 3 numbers can be divided by 7. And all of them do have a b. Sorry, I should have waited before I did the parenthesis. But we can only pull out one b because this one only has one b. So you can pull out whatever the least amount is in a term. So 35 divided by 7 is 5. And we took away one of the b's, so there's 2 left. 7 divided by 7 is 1. We took away one of the b's, so 1 is left. 14 divided by 7 is 2. And we took away the only b it has, so there's no b left there. Now on F, like I said, I recommend you look at the numbers first. 8, 24, and 56. 8 goes evenly into all of them. And they all have a y, but I can only pull out one y because that's all this middle term has. So 8 divided by 8 is 1. And you don't have to write the 1 here. Y squared divided by y is y. Because we took one of them away, one of them stays. 24 divided by 8 is 3. And y divided by y is 1, so 3 times 1 is 3, because basically we took away one y here, took away one y here, and then 56 divided by 8 is 7, and we took away one of the y's, which leaves 2 left over. Okay, G, we look at the numbers first. The biggest number that goes evenly into both of those is 5. And this has a C, so does that. So we can pull out one C because that's all that one has. They both have a D, but we can only pull out one because that's as many as the second one has. So 25 divided by 5 is 5. The C gets canceled out. One of the D's gets taken away, so one's left. 15 divided by 5 is 3. We take one of the C's away, so 2 are left over. But we took that one D away, so there's none left in that term. Sorry for that extra noise there. Okay, H. Now I know this is looking more and more complicated, but it's more so just being careful and being thorough that it is complicated. So we start with the numbers. 16, so I think like 2, 4, and 8 can go into that, which 8 works for 8, but 8 doesn't go into 22, and neither does 4. So 2 is the biggest number that we can pull out. So now I look at the P's. This one has 3 of them. This one has 2 of them. This one has 4 of them. So I can take 2 of them out. Because basically you want to look for what's the least number of P's a term has, not how many we can take out. Now we do the same with q's. There's 5 q's, 2 q's, 3 q's. So this term has the least amount of q's also. So I'll pull q squared out. So when you have lots of exponents like this, look for the smallest exponent for that variable. That's how many you can pull out front. Negative 16 divided by 2 is negative 8. We took away 2 of the p's, that leaves 1 left behind. We took away 2 of the q's, that leaves 3 behind. So I'm going to run out of room, so I'm going to go ahead and rewrite this down here so it's all in one line. Okay, 22 divided by 2 is 11. I took away both p's and took away both q's. So there's no variables left in that middle term at all, just the 11. 8 divided by 2 is 4. I took away 2 of the p's, leaving 2 behind. Took away 2 of the q's, leaving just 1 behind. And that is factoring by the greatest common factor. And if you wanted to check this in a beautiful way, you could multiply this by all 3 of these terms and find you get the same thing back, but I understand that may not be sounding like a lot of fun.